In the previous class, the column chromatography technique separation for the separation of mixed components individually, that part is completed in the previous class. Now we go for the electrogrammetry. See here, this is also one of the gravimetric technique. In this technique, the amount of the element or the ion present in the solution, or you can take electrolyte, and when a current is passed by putting electrodes, the ion of the element get deposited over the electrode depending upon the quantity of current passed. And in this technique, the electrode was previously weighed, and that is placed in the electrolyte, and on passing electric current, depending upon the standard reduction potential value, the element or the ion is going to be deposited over the electrode. After the completion, the electrode was replaced where the element or the metal is deposited. Then the difference between the previously weighed electrode and after the process, the where the metal is deposited, that was weighed. The difference between two weights gives the amount of the element present in the given solution. That can be replaced by the use of electric current, and that process was named as a electrogravimetric technique. Then in the electrogravimetric technique, what are the essential requirements? The essential requirements are here in the electrogrammetry. The first one is the deposition of the metal or a pure substance of interest must be deposited. Means there is a standard reduction potential value of the element, and depending upon that it is going to be deposited. The second one is the deposited element must be inert one, because it stick on the or it adhere on the surface of the electrode. Therefore, there is no any chemical interaction between the metal and the electrode in presence of electric current. Therefore, the care should be taken that the metal that is going to be deposited over the surface of the electrode, that must be inert one. It means there is no any change in the amount of the metal that is deposited over the surface of the electrode in its quantity as well as the composition. That is the meaning of the inertness. Then the third one is the deposited element or the compound which is going to be deposited, its composition should be known to the known. Means which element or the compound is going to be deposited. Then the depositor must adhere firmly so that the electrode can be very easily rinsed, washed, and weighed without any loss. These are the some of the points to be considered. Then, what is the principle behind the electrogrammetry? In the electrogrammetry, the principle is the electroanalytical methods are essentially based on, the first one is Ohm's law. Then what is the statement of the Ohm's law? The statement of the Ohm's law is the current strength I flowing through the conductor at uniform temperature is proportional to the potential difference E at the end of the conductor and inversely proportional to the resistance R. Here, the current strength I flowing through the conductor at uniform temperature is directly proportional to the potential value, that is E, and at the end of the conductor, and inversely proportional to the resistance, that is I is proportional to E upon R. This is the Ohm's law. Then second law is Faraday's law of electrolysis. You know what is the statement of the Faraday's law? The first law statement is the amount of the substance deposited at the electrode is directly proportional to the quantity of current passed through the electrolyte at a given temperature. Means how much current is to be passed, the equivalent quantity of the amount is deposited on the electrode at a given temperature. Suppose W is, you can write from this equation, W is proportional to C into T, or W is equal to, remove the proportionality term, W is equal to Z into C into T, where W is the weight of the substance deposited. C is the current in which is measured in amperes. Z is constant called electrochemical equivalence, and T is the time in seconds. This is the first Faraday's law of electrolysis. Suppose in this case the current is of 1 ampere is passed and for a period of time duration is 1 second, then you can write here W is equal to Z, and here W is equal to Z indicates that electrochemical equivalence. This electrochemical equivalence may be defined as, here the amount of the substance deposited at the electrode by the passage of 1 ampere of current for a period of 1 second is known as electrochemical equivalence. Clear? This is the first law of Faraday's law of electrolysis. Now we go for the second law. The second law is when the same quantity of the current is passed between two electrodes, two electrolytic solutions. We can take two electrolytic solutions are here. We can take the example of copper sulfate is there, silver nitrate is there. Means when the same quantity of, means same quantity means fixed quantity of the current is passed through different electrolytes. What happens here? The amount of the substance deposited at the electrode is directly proportional to their equivalent weights or equivalent masses. Let us consider the two electrolytes. Say you can take copper sulfate is one electrolyte and silver nitrate is another electrolyte. These two electrolytes are arranged in series. And what is to be done? The same quantity of the current is passed in the copper sulfate electrolyte as well as the in silver nitrate electrolyte. What is happened? The metal like copper plus 2, then silver plus 1, they discharge towards the electrolyte and they start to deposit over the electrode. Then what happens? The weight of the copper and the weight of the silver that is deposited on the electrode is determined. Then from this equation it is clear that weight of the copper deposited to the weight of the silver deposited is equivalent to the equivalent mass of the copper divided by equivalent mass of the silver. And from the statement it is clear that the equivalent mass of the copper is 31.8 and that of the equivalent mass of the silver is 107.8. Then this law holds good for any temperature and any concentration at various ratios in different solvents. These are the two laws, that is Ohm's law and Faraday's law of electrolysis, first and second. On the basis of these two, the instrumentation of the electrograhametric analysis is based. Okay, I'll stop here only. Tomorrow I will continue with the instrumentation of the electrograhametric technique. Thank you. Thank you for your patience hearing.